This video is going to be about Inertial Reference System alignment process. So in this airplane we have several different navigation sensors. We have 2 GPS sensors, 3 IRSs, 2 VORs, and 2 DMEs. We're starting off with all the navigation sensors disabled. So you can see the GPSs are disabled, the IRSs are all disabled, the DMEs are disabled, and the VORs are disabled. We're going to focus on just one IRS, IRS number 3, so we'll turn that one on now. And it's going to enter its alignment process, and right away we're going to get a message saying that the IRS has not had a position entry. So the Inertial Reference System consists of 3 laser gyros, and the purpose of the laser gyros are to sense rotation. So there's one that senses rotation around the yaw axis, one that senses rotation around the pitch axis, and one that senses rotation around the roll axis. And it also has 3 accelerometers, and each one of the accelerometers is sensing acceleration along each of those axes that the laser gyros are sensing the rotation around. So the way that the system works is once it knows its initial position, it takes the information from the accelerometers and from the laser gyros to determine what has changed. So it's sensing an overall acceleration in 3-dimensional space, and it's sensing our overall change in orientation in 3-dimensional space, and adding those changes to the initial position so that it can get our current orientation and our current position. And it does this completely as a self-contained unit. So it doesn't, unlike GPS, which requires signals to come to us from outside the airplane, unlike VOR, which requires radio signals to come to us from the ground, and DME, which also requires radio signals to come from the ground, the IRS is determining its position completely within itself. But the one thing it does need to know is where have we started. It needs to know the initial position, and it needs to know our initial orientation. So part of what it's doing here in this alignment process is it's trying to determine where our sort of null point is, or it's measuring the direction to true north, and it's measuring our latitude, and it's doing that by sensing the rotation, the movement of the airplane. Now, of course, right now the parking brake is on, and that's important when we're aligning the IRS. The IRS needs to be stationary in relation to the ground so that any motion that it's sensing, it will be able to attribute to the rotation of the Earth. So if you imagine the airplane sitting on the equator facing east, over time, if you were standing away from the Earth looking down at it, the airplane would be making a rotation like this along the equator, which would equate to a change in pitch attitude. So the IRS would be able to sense that over time as a pitch down. If the airplane was facing north on the equator, over time it would sense that as a roll to the right. And because of the fact that we aren't moving in relation to the ground, it will know that those rotation changes are attributed solely to the rotation of the planet. And by sensing that, it'll be able to determine the direction to true north, and therefore our heading in relation to true north, and it'll also be able to determine what our latitude is, so our angle relative to the equator. Again, we have to tell it what our initial position is so that it can build on that initial position once it's finished its alignment, and normally that is done by the GPS units. Normally when we power the airplane up, all these navigation sensors will be powered. I've intentionally depowered them for the purpose of the demonstration. So normally the GPS will automatically feed the initial position to the IRS, and when the alignment process is complete, as the IRS gets ready to go into its navigation mode, it will compare what it has calculated for a latitude to what it's been fed by the GPS, and see if there's a reasonable agreement in order for it to continue its operation. Now, since it's not going to get it from the GPS, it's going to wait for us to supply it manually. And the way I'm going to do that is by giving the FMS a position. And the FMS is our flight management system, and what the FMS does is it takes all the information from the different nav sensors and it decides on its own what is the most reliable nav sensor that's available to it. Normally that would be the GPS, and then it calculates what direction we need to travel and how much distance we're going to need to travel to get from where we are now to where we want to be. So as you can see, the FMS position is not initialized. The airplane does not know where it is, and that's why this navigation map is centered in the middle of France, because that's the default position for when the FMS is not initialized. Now we know where we are because we have a handheld GPS location here that's being fed to the iPad. You can see the Bad Elf is connected, and we are here in the northeast corner of the Washington Dulles Airport. Right here and over here, this is the hangar complex for the Dulles Jet Center, which we can see over there. So I'm going to give the IRS an initial position now, but I'm going to lie to it for the purpose of the demonstration. I'm going to give it the correct latitude, but I'm going to give it an incorrect longitude. I'm going to tell it that we're over the Pacific somewhere, but at this latitude. So we'll enter north 3857.35 and west 134 degrees. We'll apply that to the IRS, sorry, to the FMS, but since the GPS position isn't available right now, it's also going to be applied to the IRS. And you can see immediately the FMS has moved the navigation display over to the Pacific where I've entered the position. And we have a fault from our IRS saying that that position, we have a IRS 3 position entry fault. Now the reason for that is the IRS is comparing the position that we just gave it to the position that it last recalled at the end of the last flight. And it notices that there's quite a significant difference. So it's just giving us a warning that something doesn't make sense. Now, of course, there could be a valid reason for there to be such a big difference. For example, if we were flying along and we have an electrical malfunction and we lose power to one of the IRSs, and then we continue flying for another 1,000 miles or so, we land, we get a mechanic to come out to the airplane, the mechanic fixes the IRS. When we restart the airplane, that IRS obviously is not going to be in the same position as its last confirmed position during the flight. It could be 1,000 miles away, it could be 2,000 miles away. So there has to be a way for us to override that mismatch. So it's going to do the mismatch calculation, and if there's a problem, it will alert us. But it will give us, it'll still give us the opportunity to override that warning. And all we have to do to override it is enter the same position again. So I'm saying, yes, I understand that the position I just entered doesn't match where you remember us last being located, but I'm confident that the position I just entered is correct. So I'll enter it again. And we can see that the position entry fault message has disappeared. So the IRS is accepted now. Okay, since you entered it twice, I'm gonna let that slide. Now normally over here on the primary flight display, this display is powered by IRS number 1 normally, or it's fed by information from IRS number 1. And as I said before, the IRS is measuring our orientation and our position. So our orientation includes our attitude, our pitch, and our bank. It's measuring our position in 3-dimensional space, so it's able to tell us what our vertical speed is. It's also part of our orientation is what our heading is. It's also measuring our acceleration when we're on the ground, our linear acceleration. So all this is flagged at the moment because this is all being driven by IRS 1, and IRS 1 at the moment is not powered. So what we'll do is we'll switch this display to IRS 3, and you'll see the indication here. And now we can see we have our attitude indication, we have our pitch and our bank indication, we have our vertical speed indication, our acceleration has come into view, and our heading has come into view. I'm going to change this display so that it's showing the heading in relation to true north. So it's now telling us that true north is this way, and we are facing 093 degrees in relation to true north, and you can see the indication there. Over here on this primary display, this one is normally powered by IRS 2, which is also not powered at the moment, so we'll switch this one to IRS 3, and we'll get that indication here. And because IRS 3 is working, we have our attitude, our vertical speed, our acceleration, and our heading. This one will leave showing the magnetic heading. So you can see here that that is showing heading in relation to magnetic north. And we can see that it's not the same as what's shown on the left hand side. So we have a magnetic heading of 077 and we have a true heading of 093. And we also have a secondary display, and this is an emergency instrument that shows our attitude and also shows our heading. This shows 105. That's quite different from what's showing here on the left for a true 093 and what's showing here on the right for 077. The reason for that is this magnetic heading is being measured by a magnetometer in the airplane. So this instrument is actually measuring the magnetic field that's being generated around the Earth, and it's displaying our magnetic heading because it's measuring our magnetic heading. This instrument over here is displaying a magnetic heading, but it's not able to measure the magnetic heading. The IRS doesn't have the capability of measuring magnetic heading. It only has the ability of measuring true heading, because of course the Earth is rotating around the axis that passes through the true North Pole and the true South Pole. So when it sits in the alignment process and is measuring that rotation, it's measuring the rotation relative to true north, and that's how it's able to indicate our heading relative to true north, because that's what it's actually measuring. The heading that's displayed over here by the IRS, the magnetic heading, is actually a calculated heading that's based on the measured true heading and the declination for the location. So declination is the angle between the direction to true north and the direction to magnetic north. So this is an example of a chart that shows some isogonic lines, which are lines that have points along this line have the same magnetic declination. So anywhere along this blue line that's marked 10 degrees west, if I stand at any point and face true north, the direction to magnetic north will be 10 degrees to the west of true north. Over here we have this 15 degree east isogonic line. This means that anywhere along this line, if we face true north, the direction to magnetic north will be 15 degrees to the east of true north. So the IRS has an internal database of these declinations around the world, and because we told the airplane that we were here in the Pacific, it is pulling up from its database a declination that's somewhere in the neighborhood of 16 or 17 degrees east. So it knows that true north is here, and it is pulling up from its database the information that magnetic north is about 16 degrees east of true north. So our magnetic heading will be measured from where magnetic north is to where the airplane is facing, so it's going to be 93 degrees minus the declination at this point, and that's why we're ending up with 77 degrees here for the magnetic heading. This is not the correct heading for our actual location. The actual heading here, magnetic heading, is closer to this 105. So what we're going to do is reset the IRS now. And you see immediately we lose our attitude indication, we lose our heading indication. It's giving us a warning that the IRS has failed. We're going to turn it back on again. Immediately we get our attitude back, because the three accelerometers, as the airplane is sitting still, are able to detect which way is down. And based on the direction of down, it's able to determine what our pitch attitude is and what our bank attitude is while the airplane is sitting still. And once the airplane starts to move, of course, the movement of the airplane, whether it's turning or accelerating or decelerating, is going to have an effect on the accelerometers that will give a false indication of pitch and bank. So once the airplane begins to move, it's going to blend the information from the laser gyros that are measuring our rotation around the pitch, roll, and yaw axes to give us an accurate representation of our attitude. So once again, we've repowered the IRS. It's begun its alignment process. This is telling us it has 5 minutes and 30 seconds left to align. It hasn't received an initial position yet, and again, it needs that initial position to do its job. Normally that'll come from GPS, but because the GPS is unpowered, I'm going to give it its initial position. So this time I'm going to tell it the true position. I'm going to tell it that we are at this location, and we can see what will happen with the heading, the true heading, and the mag heading. So we are north 3857.34 degrees, west 077 26.45 degrees. We'll apply this. The FMS will take the map to our current position at the Dulles Airport. It still doesn't know the heading because the IRS needs to finish its alignment in order to determine the heading. But you can see that there's no position fault this time as we had the first time, because the position that I entered, it matches reasonably closely to the one that it remembers from the last time it went flying. So there's nothing really left to do until it finishes its alignment, so we'll just speed up the video here until the alignment's complete. Okay, alignment is complete. It's entered the navigation mode, so now we have our heading. Again, our true heading 093 is exactly the same as it was in the previous test. But over here, the magnetic heading that the IRS is displaying is quite different than it was previously. On the previous test it was showing 077, but now it's showing 103, which is much closer to the magnetic heading that our magnetometer is measuring and showing on the secondary flight display. Now of course the airplane hasn't moved at all. We are still in the same location near the Dulles Jet Center, facing exactly the same direction. That's why we have exactly the same true heading, because that's what was measured by the IRS. The airplane hasn't moved, so it makes sense that the true heading is exactly the same. That's what's being measured. The magnetic heading, however, has changed on this instrument, the magnetic heading that's being output by the IRS, because this isn't being measured. This is being calculated. And at this location, we have a westerly declination that's about 10 degrees that we saw on our chart. So that means that from where we are here, the direction to true north is this way. The direction to magnetic north is 10 degrees west of that. So magnetic heading is measured from magnetic north to the direction that we're facing. So that would add 10 degrees to what's indicated here, and we would end up with a magnetic heading of 103 compared to this true heading of 093. So hopefully that shows that the IRS actually measures direction relative to true north, not relative to magnetic north. It simply calculates the direction relative to magnetic north. And here you can see once the alignment process was complete, it actually shows our airplane symbol in the correct orientation heading on a true heading of 093. So now we're going to reset this IRS again. We just finished lying to it by telling it we were close to 3,000 miles west of our actual location out in the Pacific. Now we're going to tell it that we're maybe 200 miles south of our current location. And you can see when the IRS is not powered, there is no mode displayed here. We're going to power up IRS number 3 again. There we go. It's entering the align mode. 6 minutes and 24 seconds to go, and we have a warning that no position has been entered for the IRS 3 again. It needs to know, needs to be told its initial starting position, and then from that point, once its alignment is complete, it can keep track of any changes that we make to that position. So we're going to lie to it now, and instead of changing the longitude, we're going to change the latitude. But we're only going to change the latitude by a couple of degrees. So instead of 38 degrees, let's do 36 degrees 57, and we'll use the correct longitude. So we're going to say north 3657.34 and west 07726.46. Now when we apply this, just as we did before when we lied to it about the longitude, we can expect it to give us an error, since there's going to be a mismatch between the position we're giving it now and the position that it's remembering from its last flight. There you can see the map shifted just slightly. There you can see our message that there is a position entry fault. But as we did last time, the engineers were smart enough to know that there could be a very good reason for this position mismatch, so they gave us an out by allowing us to simply re-enter the position that we had entered before, which was 3657.34 north and 07726.46 west. When we apply that, we should expect to see the fault message go away. And there it goes. So we're telling the IRS by entering the same position twice, yes, we are absolutely sure that this is the correct position. And the IRS is saying, well, you must know better than I do. Okay, I'll go ahead and accept that now. Now the key point here is we're still in the align process, so it's still in the process of calculating its latitude. It's still sensing this very, very slow rotation. So these laser gyros are incredibly sensitive. Once the alignment process is complete and it has finished its calculation of the direction to true north and its latitude, it's going to compare that latitude to the latitude that's being shown here. If there's a mismatch, it's going to throw up another fault message, which we did not see when we lied to it and told it we were out over the Pacific. And the reason for that is we gave it an accurate latitude in that test, but a wildly incorrect longitude. Unfortunately, while it's sitting here in the alignment mode, it really has no way of calculating its longitude. And that's why we have to give it a correct starting position. So we'll speed up the video here, make it through the alignment process, and then see what happens. Okay, alignment is now complete, but it hasn't switched to navigation mode, and the reason for that is because now that the alignment is complete, it's given us another position entry fault. So the reason for that is, now that the alignment is complete, it's finished measuring its latitude, and it's comparing the latitude that it measured to the latitude that we entered, and it's saying, wait a minute, that doesn't match up. Are you sure? It'll give us another opportunity to enter the correct position. Now we're going to enter the same position again as we've done in the past to try to clear that message. And again, this position is just 2 degrees of latitude south of our correct location. Now when we apply this, let's see what happens. Immediately, we've lost our attitude indication. IRS 3 is now also failed, but notice that it still shows a mode. So if we look at what it looks like when IRS 2 is failed because it's off right now, and you can see that there is no mode. IRS 3 is failed for a different reason. You see the mode is being shown, so IRS 3 is still being powered. I didn't turn it off. The reason it failed this time is because I insisted on entering a position with an incorrect latitude. It didn't have any trouble when I did that with an incorrect longitude that was several thousand miles away, but when I entered a latitude that was 120 nautical miles away, once it finished calculating for itself by sensing the Earth's rotation, once it finished calculating for itself the latitude that it is expecting, and I insisted on entering an incorrect latitude, it's now saying, well, I, the IRS, am sure that that's not the right latitude. You, the pilot, seem to be very sure that it is the right latitude because you keep entering it. So I, the IRS, now have to assume that there's something wrong with me, that I'm malfunctioning because I'm not coming up with the same latitude that you, the pilot, are coming up with. So I'm going to take myself out of the available navigation sensors pool and call myself failed, because the IRS is now assuming that it must be failed if I'm so confident that our latitude is really 2 degrees away from the latitude that it's computing. It's quite different than what it did when we entered an incorrect longitude. I was quite happy to accept an incorrect longitude as long as the latitude was reasonable. Now, we're going to restart this IRS and try again. So here we have it. You can see that there's a mode indicated there, so it's failed not because it doesn't have power. When I remove the power, you'll see that the mode is going to disappear. Now that's what it looks like when it's powered off. So we're going to restart IRS number 3. There we go, we've got power again. We got our attitude back immediately. It's giving us a warning that it doesn't have its initial position. Somebody please help me out. I need to know where we are to start. Now we have 6 minutes and 6 minutes and 12 seconds to go in the alignment process. So this time we're going to try to lie to it again in terms of latitude. What if we gave it the correct angle? So what if we said we are at 38 degrees 57 minutes, but instead of saying north, we say south. So we're going to put it on a latitude circle that has the same circumference as the correct latitude circle, but in the wrong hemisphere. And let's see how it handles that. So we're going to say south 38 degrees 57 minutes and 0.34, and west 07726.47, which is the correct longitude. We're going to apply this, and we'll immediately see the map shift to South America when the FMS takes up this new position. We'll immediately see an IRS 3 position entry fault. Now this again is the entry fault because it's comparing what we just entered to what it has stored in memory for its last known position at the end of the last flight. So again, we'll try to override that warning, because as we said, the engineers recognize that there could be very valid reasons for there to be a mismatch, and they've allowed us to override it by simply entering it twice. We're going to apply that, and we see the position entry fault has gone away. So this is a different position entry fault than the one that happened in the previous example the second time around. So the first time we have a position entry fault because the position we just entered doesn't match where it thinks we were the last time we finished flying, but it's still trying to figure out its latitude right now. It's still calculating its latitude, and it's still calculating its direction relative to true north. So we'll speed up the video to get through the alignment process and see what happens. So here we are, the alignment process is complete. But again, it's giving us an IRS 3 position entry fault, because now that it's finished measuring the latitude for itself, it's comparing that latitude to what we've entered. And even though we've entered the same angle that it's sensing, because it's in the wrong hemisphere, it knows that that is not quite correct. So this is different from just comparing its current entry here to what is remembering from where it was when it got shut down, because as we've seen before with the longitude entry, you can easily override that because there is a good reason. There are reasons why those two positions may not match. So let's try putting this position back in again to override this warning. We'll apply it, and immediately we'll lose our attitude indications, we'll lose our heading indications, and IRS number 3 goes into its failure mode. I haven't turned it off, I haven't removed the power, because you can see it still shows a mode, but it's not going to be available for use. This is what it looks like when the power has been removed. That's IRS 2. IRS 3 is failed for a different reason. The power is still there, but it's not going to allow itself to be used because I keep telling it that we are at a latitude that does not match the latitude that it measured in its alignment process. So let's try one more time. We're going to turn IRS 3 off. Turn it on again. Immediately we get our attitude back. It's reminding us that, hey, somebody needs to tell me where we are to begin with so I can do my job. We're going to try again to lie to it and tell it that we are south 3857.34 and west 07726.47. Again, this is the correct angle relative to the equator, so the circumference along this line of latitude is going to be the same as it is at our correct location, and it is the correct latitude. So we'll apply this. The map, of course, isn't going to move because it's the same position that I've given it previously. We will get a position entry fault because the position that we just entered doesn't match the IRS's last recorded correct position. But as we've seen before, they've built in a way for us to override that warning, just in case there's a good reason for there to be a mismatch. So we'll apply that. That'll take the fault away, and now we'll wait for the alignment process to complete. So we'll go ahead and speed up the video here. Alignment process is complete, but it hasn't gone to navigation mode because, once again, not surprisingly, it's sensing an IRS 3 position entry fault, because once again, now that the alignment is complete, it has measured for itself what the latitude should be, and there's too much of a mismatch between its measured latitude and the latitude we gave it. So this time, instead of trying to re-enter the same position, which we know is going to cause it to fail, let's enter the correct position. So we're going to enter north 3857.19 and west 07726.44. We're going to apply this. It's going to cause the map to shift, and let's see what the IRS does with that. It's moved us to where we should be in Washington, Dulles. It's taken away our position entry fault, and it's gone into navigation mode because the position that I just entered matches in terms of latitude very closely to what the IRS has measured. So it's happy with that, and instead of failing as it did in the previous tests, it moves us into navigation mode, and it's quite happy. And you can see on the chart that again, alignment is complete, so it has correctly measured the direction to true north and therefore knows the airplane's orientation in relation to true north. It has calculated our magnetic heading by looking up the declination. Now you may notice that the magnetic heading here of 103 didn't match the magnetic heading that's being measured here on the secondary instrument of 105. One of the reasons for that is because of the fact that the magnetic pole is constantly moving. The declination is actually slowly changing everywhere. So the table that the IRS is using to look up the declination isn't exactly the correct declination today, because declination changes over time. So there's going to be, that's part of the reason there's going to be a slight difference between what this calculates for magnetic heading and what may actually be the perfectly accurate magnetic heading, but it's normally going to be within a degree or two of what the correct magnetic heading should be, and that small a difference doesn't really have any effect in the day-to-day operation of the airplane. The other reason is this is not necessarily 100% the correct magnetic heading, because the magnetometer itself can have some small errors as well. And then finally we can take a look at where the airplane now thinks we are. And here it's showing us in the northeast corner of the Washington Dulles Airport. And this is the Dulles Jet Center that we saw previously. Thanks for watching.